children, how are you? I think all are fine. I am Sandhya, working as Math CRT at Kurugunta in Anantapuramu district. During this pandemic situation, our Sarva Shiksha Abhiyan conducting online classes in this academic year. So, let us begin our class with logarithmics topic. Children, earlier you would have learned properties of exponents and powers. Once again, we will revise today. 2. 2 can be written as 2 into 1. This can be also written as 2 to the power of 1. 4. 4 can be written as 2 into 2. Here 2 is multiplied by 2 times. That means 2 square. 8. 8 can be written as 2 into 2 into 2. Here 2 is multiplied by 3 times. It can be also written as 2 cube. 16. 16 can be written as 2 into 2 into 2 into 2. Here 2 is multiplied by 4 times. This can be also written as 2 to the power of 4. 32. 32 can be also written as 2 into 2 into 2 into 2 into 2. Here 2 is multiplied by 5 times. So this can be also written as 2 to the power of 5. Similarly, by continuing this process, A can be multiplied with m times. This can be written as a to the power of m. In a to the power of m, a is called base, m is called exponent. Here, a is equals to base, m is equals to exponent. Next, we will learn how to convert the exponential form to logarithmic form. Exponential form. To logarithmic form. Example, 2 cubed is equals to 8. This is in exponential form. 2 cubed means 2 can be multiplied by 3 times. That is 2 into 2 into 2. 2 2s are 4, 4 2s are 8. How to convert this 2 cubed equals to 8 into logarithmic form means, first you write log symbol. First you write log symbol. Beside that you write resultant value, and then you write base value. Just below the log symbol, which is equal to the exponent value. Now we will discuss some more examples. Example 2. 5 to the power of 4 is equals to 625. 5 to the power of 4 means 5 can be multiplied by 4 times. 5 into 5 into 5 into 5. 5 5s are 25. 25 5s are 125. 125 5s are 625. How to convert this 5 to the power of 4 is equals to 625 into logarithmic form? First you write log symbol. Beside that you write resultant value. And then you write base value just below the log symbol, which is equals to the exponent value. One more example. Example 3. 6 cube is equals to 216. 6 cube means 6 can be multiplied by 3 times. 6 into 6 into 6. 6 6 are 36. 36 6 are 216. How to convert this 6 cube is equals to 216 into logarithmic form? Log 216 base 6 is equals to 3. Next, one more example. 2 to the power of 10 is equals to 1024. This can be converted into logarithmic form. Log 1024 base 2 is equals to 10. Similarly, if a to the power of x is equals to n, then log n base a is equals to x. The another form of exponential form is logarithmic form. Now we will write the definition of logarithms. Definition. If a to the power of x is equals to n, then log n base a is equals to x, where a greater than 0, a is not equals to 1, comma, n greater than 0, and a comma n belongs to R. Here R means real numbers. If a to the power of x is equals to n, then log n base a is equals to x, where a greater than 0, a is not equals to 1, n greater than 0 and a comma n belongs to R. Here a comma n belongs to R means a comma n values real numbers లో ఉంటాయని అర్థం. Again a is greater than 0, n is greater than 0 అంటే ఇక్కడ a and n values 0 కన్నా బిగ్గర్ నెంబర్స్ తీసుకోవాలి. అంటే we take only positive values. You don't take negative values. And also one more condition, a is not equals to 1. a value 1 కని తీసుకోకూడదు అని అర్థం. Again logarithms are divided into two types. One is natural logarithm, another one is common logarithm. Logarithms can be divided into two types. One is natural logarithm, another one is common logarithm. Logarithms. Natural logarithms, common logarithms. Natural logarithms are invented by John Napier. Common logarithms are invented by Henry Briggs. Base E logarithms are called as natural logarithms. Base E logarithms Base E logarithms are called as natural logarithms. Base 10 logarithms are called as common logarithms. Base 10 logarithms are called as common logarithms. Example, The example of natural logarithms are log 2 base e, log 3 base e, etc. The examples of common logarithms are log 5 base 10, log 7 base 10, etc. The another form of log x base e. Log x base e is also written as ln of x. Log x base e is also written as ln of x. Log x base e is also written as ln of x. In common logarithms, log x base 10 is also written as log x. Log x base 10 is also written as log x. Now we will discuss properties of logarithms. Basic properties of logarithms. Number 1. 2 to the power of 0 is equals to 1. This is in exponential form. This can be converted into logarithmic form is log 1 base 2 is equals to 0. Again, 5 to the power of 0 is equals to 1. This can be also converted into logarithmic form is log 1 base 5 is equals to 0. Similarly, 7 to the power of 0 is equals to 1. This can be also converted into logarithmic form is log 1 base 7 is equals to 0. In general, if a to the power of 0 is equals to 1, then log 1 base a is equals to 0. Here the condition is a is always not equals to 1. Therefore, log 1 base a is equals to 0. Here a is not equals to 1. This is called first property of logarithms. Again, we go to the second property. 5 to the power of 1 is equals to 5. This 5 to the power of 1 is equals to 5 is in exponential form. This can be converted into logarithmic form is log 5 base 5 is equals to 1. Again, 7 to the power of 1 is equals to 7. This can be also converted into log 7 base 7 is equals to 1. 13 to the power of 1 is equals to 13. This is in exponential form. This can be also converted into logarithmic form is log 13 base 13 is equals to 1. In general, If a to the power of 1 is equals to a, then log a base a is equals to 1. Here the condition is a is always not equals to 1. Therefore, log a base a is equals to 1. A is not equals to 1. This is called second property of logarithms. Again, we go to the third one. This third one is product rule. This third one is product rule. What is the third property means? Log xy base a is equals to log x base a plus log y base a. So what is the proof of this third property means? Let us assume that log x base a is equals to m. Let log x base a is equals to m and log y base a is equals to n. These two are in logarithmic forms. So you convert these two into exponential forms. That means log x base a is equals to m. This can be converted into exponential form is a to the power of m is equals to x. This is considered as equation 1. Again, log y base a is equals to n. This can be converted into exponential form is a to the power of n is equals to 5. This is considered as equation 2. Multiplying the equations 1 and 2, we get a to the power of m into a to the power of n is equals to x into y. We know the formula of a to the power of m into a to the power of n means a to the power of m plus n. That is equals to x into y means xy. This a to the power of m plus n is equals to xy is in exponential form. So you convert this one into logarithmic form is log xy base a is equals to m plus n. We know the values of m and n. Substitute the m and n values in the above equation. We get log xy base a is equals to the value of m is log x base a plus the value of n is log y base a. Since m is equals to log x base a and n is equals to log y base a. This is the proof of third property. Therefore, log xy base a is equals to log x base a plus log y base a. This is called product rule. What are the applications of this product rule means? So, log PQR base a means this can be converted into log P base a plus log Q base a plus log R base a. For example, log 15 base 2. Log 15 base 2. What is the value of log 15 base 2 means? This 15 can be written as 3 into 5 base 2. So this is in the form of log x into y base a. So this can be converted into log x base a means log 3 base 2 plus log 5 base 2. Since log xy base a is equals to log x base a plus log y base a. Therefore, log 15 base 2 is equals to log 3 base 2 plus log 5 base 2. Again, the next rule is quotient rule. This is fourth property of logarithms. Quotient rule. So what is the fourth property means? Log x by y base a is equals to log x base a minus log y base a. What is the proof of this fourth property means? Proof. Let us assume that log x base a is equals to m and log y base a is equals to n. These two are in logarithmic forms. So you convert these two into exponential forms, or if log x base a is equals to m, then a to the power of m is equals to x. This is considered as equation 1. If log y base a is equals to n, then it can be converted into logarithmic form is a to the power of n is equals to y. This is considered as equation 2. Dividing the equations 1 and 2, we get equation 1 by equation 2. That is a to the power of m by a to the power of n is equals to x by y. We know the formula a to the power of m by a to the power of n means a to the power of m minus n. That is equals to x by y. This is in exponential form, so you convert this one into logarithmic form means log x by y base a is equals to m minus n. We know the value of m. What is the value of m means log x base a minus n means log y base a. Therefore, log x by y base a is equals to log x base a minus log y base a. This is called quotient rule. This is the fourth property of logarithms. What are the applications of this quotient rule means? Applications. Log PQ by R base A is equals to log PQ base A minus log R base A. Again, this log PQ base A is in the form of log XY base A. That means here this log xy base a can be converted into log x base a plus log y base a. Similarly, log pq base a can be converted into log p base a plus log q base a minus log r base a. Log p cube by r base a is equals to log p base a plus log q base a minus log r base a. One more application. Log p by q base a is equals to log p base a minus log q base a. I will explain one more example. What is the value of log 8 by 5 base 11? What is the value of log 8 by 5 base 11? This is in the form of log x by y base a. This can be converted into log x base a minus log y base a. Similarly, log 8 by 5 base 11 can be converted into, here x means 8 and y means 5, a means 11. Log x means log 8, a means 11. That means log x base a means log 8 base 11 minus log y base a means y means 5, a means 11. That is log 5 base 11. Again, the fifth property. Log x to the power of m base a is equals to m log x base a. Example, log 5 to the power of 4 base 3 is equals to 4 log 5 base 3. The fifth property is log x to the power of m base a is equals to m log x base a. Again, we go to the sixth property. Log x base a to the power of m is equals to 1 by m log x base a. Example, log 3 base 2 to the power of 5 means, here the value of x is 3 and the value of a is 2. The value of m is 5. So this can be converted into 1 by 5 log 3 base 2. Again, we go to the seventh property. Log x base a is equals to, this can be also written as 1 by log a base x. Example, log 2 base 3, which can be written as 1 by log 3 base 2. The eighth property is log x to the power of m base a to the power of n is equals to m by n log x base a. Example, log 2 cube base 4 to the power of 7 means 3 by 7 log 2 base 4. Again, the ninth one, log 1 by x base a is equals to log 1 by x. Here x power is 1. This 1 by x can be converted as x to the power of minus 1 base a. This can be also written as, this is in the form of log x to the power of m base a. So we convert this one into m log x base a. That is minus 1 into log x base a. That means minus log x base a. So these are the properties of logarithms. The last 10th property is a to the power of log x base a is equals to x. Example, 2 to the power of log 5 base 2 is equals to 5. So these are the properties of logarithms. Now we summarize all the properties of logarithms into formulae. If a to the power of x is equals to n, if and only if log n base a is equals to x, a greater than 0, n greater than 0, a is not equals to 1, and a comma n belongs to all. Log 1 base a is equals to 0. A is not equals to 1. Log 1 base a is equals to 0. A is not equals to 1. Next one. Log a base a is equals to 1. A is not equals to 1. Next. Log xy base a is equals to log x base a plus log y base a. Log x by y base a is equals to log x base a minus log y base a. Log x to the power of m base a is equals to m log x base a. Log x base a to the power of m is equals to 1 by m log x base a. Log x base a can also be written as 1 by log a base x. Log x to the power of m base a to the power of n can be written as m by n log x base a. Log 1 by x base a is equals to minus 1 into log x base a. A to the power of log x base a is equals to x. Note: log 0 base a value does not exist. For negative numbers, logarithms does not exist. Example, log minus 1 by 5 base 3 value does not exist. But the result of a logarithm may be a negative number. Example, log 1 by 8 base 2 is equals to log 1 by 8 can be written in exponential form is 2 cube base 2 log. This 1 by 2 cube can be written as 2 to the power of minus 3 base 2. Again, this is in the form of log x to the power of m base a, which equals to m log a, m log x base a. So, log 2 to the power of minus 3 base 2 can be converted as minus 3 log 2 base 2. Minus 3 log 2 base 2 is in the form of log a base a. We know the log a base a value, that is equals to 1. So log 2 base 2 value is always equals to 1. Minus 3 into 1 means minus 3. We will continue the next class.